Hello again, my little mathematicians. Today we're going to explore some more about ratios. We're going to focus on equivalent ratios and how to use that to help us solve problems. So let's first focus on this warm-up up at the top to remember how to create an equivalent ratio. So if I look for problem 1, here's the initial ratio, 5/8. What would this number on top of 64 have to be to make this ratio be equivalent to 5/8? And what would this one down below of 60 have to be equivalent to 5/8? Since this is a warm-up, I want you to try these on your own. So press pause and then unpause it when you think you have them. All right, now that you're back with us, let's see if you got them right. When you're creating equivalent ratios, as long as you do the same thing to both the top and the bottom, they'll be equivalent to each other. So think to yourself, what did you do to 8 to become 64? Well, you multiplied it by 8. So then do the same thing on top. Multiply 5 times 8 and you get 40. So that means 40/64 is equal to 5/8. The next one says, okay, what did you do to 5 in order to get 60? Well, you multiplied it by 12. So then do the same thing on the bottom. Go ahead and multiply 8 times 12. And 8 times 12 is 96, which means 60 over 96 is equivalent to 5/8. If you got that right, congratulations. I'm going to go ahead and just rewrite this middle one off to the side so I have more space. So something over 21 and 5 over 7 and something over 105. Well, the first thing is I can go from 7 to 21 if I multiply by 3. So then do the same thing here. 5 times 3 is 15. So that blank would have been 15. The next one says 7 times what is 105? I don't know that off the top of my head. How about you? So I'd have to probably do some long division there. Well, 7 can't go into 1, but it can go into 10 once. When you subtract that, you get 3. Always double check that your remainder is smaller than what you divided by. If it isn't, erase this and try again. You didn't pick a big enough number. But 3 is bigger or smaller than 7, so I can go ahead and keep going, bring down that 5. 7 goes into 35 5 times. 7 times 5 is 35. Subtract, you get 0. It went in evenly, so I can say that 7 times 15 is 105. Do the same thing to the 5. 15 times 5 is 75. Okay, and finally, our last ones. Now, if you missed any of those, maybe you want to pause it again and retry these ones and then check yourself. Okay, and now that you're back with us, okay, there's a trap for this one. A lot of people want to go, oh, 4 times 8 is 32. And so then they're like, 72 times 8 would go here. Always go towards the direction of the unknown. So like from here to here, how would you get there? So then I'm going to go from here to here. How would you get there? So I didn't multiply by 8, but I divided by 8. That may not seem like a big difference, but it is. And just doing that simple little thing of drawing the arrow towards where the unknown is will help you make less mistakes. Okay, so 72 divided by 8 is 9. So that blank should have been 9. And remember, another way to double check that you have it right is each ratio should always reduce to the same thing in simplest form. 4/9 is already simplest form, and if you reduce 32 over 72, you guessed it, you'd get 4/9. So that was our first blank there, should have been a 9. And then for this last one, okay, I'm going, I can't go from here to here, so I'm going to have to use this fraction to get there. So go from there to my unknown and from there to my unknown. How do you go from 4 to 48? Well, you multiply by 12. So then you're going to multiply 9 times 12. And 9 times 12, if you don't know that, go ahead and work it out. And you get 108. So that was our last unknown. Okay, so that was a little bit of a review of how to create equivalent fractions. Hopefully you did pretty well on that. And we're going to use that to help us get started on our notes. Our first example says, using the above table, write a ratio for how much Sean, you know what, I'm going to draw some attention to that because there's multiple people here. Okay, so Sean is who I'm focusing on. How much did he spend on games to the amount he spent on souvenirs? So Sean souvenirs and Sean games. Now, one thing is when you're writing ratios, you're dealing with word problems, we always want to write the words in front. Okay, so we're focusing on Sean, and I'm going to do games first and souvenirs second, because games came first, and then after the word to came souvenirs. Okay, souvenirs was 12, and games he spent 8. Always double check to see if you can reduce a ratio. This one can reduce. I see that 4 can go into both of those. So 8 divided by 4 is 2, and 12 divided by 4 is 3. And I can't reduce it anymore, so I'm done. Some of you guys may have only reduced it by 2, and then you saw you could reduce it again, so you had to reduce it by 2 again. The bigger number you choose to reduce by, the faster you get there. As long as you ended with 2/3, you're correct. Okay, the next one says, if he, Sean, spends 24 on games, how much will he spend on souvenirs? So let's keep that same ratio. Okay, we have games to souvenirs. And we know that that ratio is 2 to 3. So keeping with that, they ask if he spent 24 on games, so that 24 matches with games and games is on top. Now you see the important thing of why we write the words in front, because then I know where to put my 24. How much will he spend on souvenirs? So this is my unknown. So now I kind of do that practice of what we did up above in our warm-up of creating equivalent ratios to find my unknown. How did I go from 2 to 24? Remember, you always want to go towards the direction of your unknown. Well, 2 times 12 gives me 24. So 3 times 12 is 36, which means he spent $36 on souvenirs. Go ahead and see if you can try C and D following the same way we did A and B. But remember, this time we're not focusing on Sean. This time we're focusing on Ryan. So you'd pause the video and then come back when you think you have it figured out. Okay, now you're back with us. We're going to focus on Ryan, as we said. Okay, and I want to know how much he spent on souvenirs to the amount that he spent on snacks. Okay, well, Ryan on snacks was 10. And on Ryan's souvenirs, if I look at the table, was 20. Think to yourself, can you reduce that? Yes, I can. By 10. Some of you guys did by 2 and then by 5, or by 5 and then by 2. Regardless, when you ended, you should have gotten 2 on top and 1 on the bottom. So it's in a 2 to 1 ratio, which means he spent double the amount on souvenirs than he did on snacks. Okay, now I'm going to use that ratio to help me find this unknown one. So again, we're focusing on Ryan. We're going to use this ratio from here. It says if he spent $12 on snacks, how much did he spend on souvenirs? So let's do that same thing of souvenirs to snacks. And we know that snacks, he spent $10 for every $20 that he spent on souvenirs. And I'm going to use that to help me find the other part. Well, they told me 12, but 12 is talking about snacks. And where are snacks? On the bottom. And this is, again, why it's so important to put the words in front, because here, the number they gave us, we put on top. Here, the number they gave us, we put on the bottom, because it was talking about snacks, and snacks goes on the bottom. Here was talking about games, and games was on top. So it's very important to always keep your ratios lined up, okay? And that's why we put the words in front. So now I can use my ratio to help me create this equivalent ratio and help me find the unknown. Okay, and you're like, that doesn't really help me, because how do I go from 10 to 12? And then you're like, oh, that's probably why it's always best to write your ratios in simplest form. So remember that we reduced this to 2/1, okay? So now it's easier to see, how do you go from 1 to 12? Well, you multiply it by 12. And how do you go from 2 to the unknown? You do the same thing you did on the bottom. If I multiply by 12 here, I multiply by 12 on top. And 2 times 12 is 24, which means Ryan spent $24 on souvenirs, which makes sense because it was supposed to be double the amount he spent on snacks, because earlier we said however much he spent on snacks, he spent twice that amount on souvenirs. And that's how you use ratios to help you solve for unknowns. Congratulations on mastering yet another standard.